All right, here we go, back again. Oops. Sorry about the delay in getting this done. It has been a hectic week, as I'm sure it has been for you all. So let's go ahead and get started with our activity for the day. Uh-oh. Here we go. All right, question number 1. Find all solutions of the equation in the interval from 0 to 2 pi, including 0. So 2 sine of theta minus root 2 is equal to 0. We solve it like we do a regular equation. Plus root 2 on both sides. All right, and for the future, I'll just say that I'm adding to both sides and maybe not write it, but maybe so, we'll see. 2 sine of theta is equal to root 2 divided by 2 sine theta is equal to root 2 over 2. Now, to be thorough, I'm going to say theta is equal to arc sine of root 2 over 2. But we all know that this and this mean the same thing. Okay, so where is theta? Where is sine of theta equal to root 2 over 2? Well, we already know that that is from 0 to 2 pi. So the answer is pi over 4 and 3 pi over 4. And that's theta. Or maybe I don't have to do the set brackets because Alex wouldn't answer that. So pi over 4, 3 pi over 4. Let us continue. All right, same type equation, only we're dealing with inverse. Not the inverse sign, but the reciprocal. So root 3 cosecant of theta minus 2 is equal to 0. Root 3 cosecant of theta is equal to 2. I added 2 to both sides. Cosecant of theta is equal to 2 over root 3. I divided both sides by root 3. And we know that the cosecant, we can take the reciprocal of both sides. Okay, so we know that sine of theta is equal to root 3 over 2. Or theta is equal to arc sine of root 3 over 2. Where does sine equal root 3 over 2 from 0 to 2 pi? That is equal to pi over 3 and 2 pi over 3. Pretty easy, right? These aren't bad. Mostly. Whoa. Whoa. Go back up. Got away from me there. All right, find all the solutions of tan of theta is equal to 0.7167. Now, I need to draw a circle for you to see something. Tangent of theta for everywhere in quadrant 1. Let's say here. We know that it is also here in quadrant 3 because quadrant 1 and quadrant 3 are where tangent of thetas are equal to positive numbers. So the difference between these, they are pi apart from each other. So whenever we have a solution over here, it's going to be a solution over there. So let's do it. So this we're going to take the arctangent theta is equal to arctangent of 0.7167. All right, and if I do that, make sure that you are in radians because there is no degree sign here. All right, so radians arctangent of 0.7167. All right, so my first theta that I get is round to the nearest hundredth. 2. That's my first one. Okay. And if I do plus that, yeah. And if I add pi to it, because we're in radians, so this angle and this angle, these are pi apart from each other. Here and here. And that goes for anywhere in quadrant 1. So they're pi away from each other. So I add pi to that, and I get 3.76. We're going to use this later, by the way, with this kind of principle or property. Okay, this part down here, do not run any intermediate computations. It's cool that they say not to do that. That's a matter of course. We don't normally do that in math because then you get round off error. Whoa. Solutions to the equations. Okay, here, but it's saying here, give all the solutions. So this 2 pi k means all k times every rotation. So in other words, every rotation counts. Every forward rotation, every backward rotation, because it's 2 pi. This is also written sometimes as 2 pi k, which I like better because it shows the 2 pi and it shows you that it's different rotations. This is k is a member of the group of integers. Most of us haven't had set theory, but this z bar is a symbol for integers, the set of all integers. So whenever you see this, this is the angle measure plus all the rotations of this angle measure, because it's 2 pi times integers. So times -1, 0, 1, 2, 3, 4, all whole numbers, positive and negative, and 0. So this is all rotations. Okay, so let's do it. Hopefully you've seen that before. All right, so √3 cotangent of theta minus 1 is equal to 0. √3 cotangent of theta is equal to 1. Cotangent of theta is equal to 1 over √3. Flip both of them, we get tangent of theta is equal to √3. So theta is equal to the arctangent of √3. Where is that located at? There are two places that arctangent is going to be positive. Okay, those two places are at pi over 3, and also my right below it, and also at 4 pi over 3. Sorry about that. At these two places. Okay. So, but these two things, so normally we would write pi over 3 plus 2 pi k, where k is in integers, or 4 pi over 3 plus 2 pi k, k is in integers. All right, but if you look at where that is on the unit circle, that's saying here and here. So in other words, it's here, then I go around to here, then I go back around to here again, then here again. So in other words, I can combine these two things, and I can say pi over 3 plus pi k, where k is in the group of integers. Because from pi over 3 to 4 pi over 3 is pi apart from each other. And then we're going, like I said, we're going from here to here to here to here to here to here. So we keep going pi each time. So this is just a simplified way to do it. You can't do this every time, but when you can do it, you should do it. Okay. Again, we're going to see all this again. Find all solutions to this. So we end up with two instances. So we end up with 2 cosine of x plus √2 is equal to 0, and 2 sine of x minus root 2 is equal to 0. Solve both of them. So 2 cosine x is equal to negative root 2. So cosine x is equal to negative root 2 over 2. So x is equal to the arc cosine of negative root 2 over 2. That means that x is equal to, where is cosine equal to negative root 2 over 2? It's going to be in the second and third quadrants. So that's going to be 3 pi over 4 and 5 pi over 4. All right. So 2 sine of x minus root 2 is equal to 0. 2 sine of x is equal to root 2. Sine of x is equal to root 2 over 2. So x is equal to the arc sine of root 2 over 2. It's in the first and second quadrant. So that x is equal to pi over 4 and 3 pi over 4. So the total answer to this is pi over 4, 3 pi over 4, and 5 pi over 4. Pretty straightforward. But this is showing the concept of telling multiple answers, which, again, we're going to need that. Let us continue. Find all solutions, same type deal. So let's do it. So 3 tangent squared of x minus 1 is equal to 0. 3 tangent squared x is equal to 1. Tangent squared x is equal to 1 over 3 divided by both sides by 3. Here's where the trick comes in. So tangent of x is equal to plus or minus square root 1 over root 3, which is plus or minus root 3 over 3. Okay, so if we take all the positive and negatives, root 3 over 3's, that's all of our tangents. So that's all of them. All right. So that question is, where's tangent? Oh, I'm sorry. Tangent of that. So x is equal to arctangent of plus or minus root 3 over 3. So that is pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Now I know that some of you might be saying, hey, but this arctangent, you know, about the range of that. But it tells us the interval that we're looking at over. This is kind of standard to look over this interval. Let's keep that in mind. Let's keep going. All right, find all solutions of the equation in this interval. So 4 sine x is equal to negative cosine squared x plus 1. We're going to use something in here that we haven't used yet, but I'm not going to say it's cool to use, but it's a thing to use. We use one of our identities. So 4 sine x is equal to negative cosine squared x plus 1. Now we would like everything to be in terms of sine and cosine. So we're going to put everything in terms of sine because it's easier. So 4 sine x is equal to negative cosine squared x is equal to 1 minus sine squared x plus 1. Okay, so 4 sine x is equal to negative 1 plus, you have to distribute that, sine squared x minus 1. Cancel, cancel. We're going to subtract 4 sine x from both sides because I like for my first term to be positive. So end up with 0 being equal to sine squared x minus 4x. I mean 4 sine x. I should definitely fix that. I have a kid that will fuss at me if I don't have that right. All right, and sine squared x is sine of x squared. So 0 is equal to sine of x times sine of x minus 4. So that means that this term, this times this is equal to 0. So we have sine x is equal to 0. So x is equal to arc sine of 0 in our usual interval. So that is going to give us 0 and pi. All right. And then we have sine x minus 4 is equal to 0. Sine of x is equal to 4. Well, this is not a solution because sine of x is never equal to 4. The range of sine is from -1 to 1, inclusive. So that's our answer from 0 to pi. All right. Try not to speed through this too much, but there is a particularly challenging problem that I want you to see. We are almost there. All right, using more identities. Cosine of 2x plus cosine of x is equal to -1. We like everything. The 2x kind of messes us up. So we want to get rid of that. We want everything in cosine still. So we know that cosine of 2x is 2 cosine squared x minus 1 plus cosine x is equal to -1. Well, I can add 1 to both sides to get rid of that, these ones. And I end up with 2 cosine squared x plus cosine x is equal to 0. So that is cosine x times 2 cosine x plus 1 is equal to 0. So cosine x is equal to 0. We know that x is equal to pi over 2 and 3 pi over 2. All right, 2 cosine x plus 1 is equal to 0. We know that 2 cosine x is equal to -1. Means cosine x is equal to -1/2. X is equal to arc cosine of -1/2. And that means that that is equal to -1/2. So that is 2 pi over 3 and 4 pi over 3. So these are my answers. So it's all of them together. So I should do it like this. X is equal to pi over 2, 2 pi over 3, 4 pi over 3, and 3 pi over 2. Okay, those are in order. So we like to have them in order. All right. Number 9 is the one that I've been waiting for. There is a degree of challenge to this problem. But hopefully I can explain it so that it makes it easy for you. Or easier for you. All right, suppose an airplane is asked to stay in a holding pattern near an airport. The distance of the plane to the airport is described by the following, that formula. D of t is equal to 139 plus 73 sine of the quantity pi over 5t. In this equation, d of t is the distance of the plane to the airport in miles, and t is the time in minutes after the plane enters the holding pattern. During the first 10 minutes after the plane enters the holding pattern, when will the plane be 170 miles from the airport? Okay, intermediate, blah, 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 blah. So let's go on up here where we have space. So the distance is 170. So 170 is equal to 139 plus 73 sine of pi over 5t. Algebra. 70 minus 39, that is 31. So 31 is equal to 73 sine of pi over 5t. Divide both sides. 31 over 73 is equal to the sine of pi over 5t. All right, here's where we start getting tricky. So arc sine of 31 over 73. Arc sine is equal to pi over 5t. If you think about it, well, let's do it like this. Unit circle. You know I like drawing these. Okay, so I'm taking the arc sine of 31 over 73. So actually, let's erase the circle part. So I'm taking the arc sine of 31 over 73. So there's 31 over 73. But it's also here too. 31 over 73. So I'm going to have two answers. So whatever this angle theta is here, I also have to do pi minus theta for this angle there. Okay. So if I take the arc sine of this, and again, we are in mode. We're in radians. Arc sine of 31 over 73. And I get 0.438, so on and so forth. Okay. Hold on. Yeah. Okay. So sine of theta is equal to this number here. Hold on. Lost my notes. Okay, well, hope I remember. Okay. So sine of theta is equal to this. And that is this angle here. All right. But I could take the arc sine of this angle here and get the same thing because it's the same ratio. So I can do pi, where are we at? No, hold on. No, that's the wrong problem. All right, here we go. So I have this, and then I'm going to do pi minus this angle here. 0.438, so on and so forth. I'm going to do pi minus that. All right, and that gives me 2.703, so on and so forth. Okay, I'm not now. Although I'm rounding these when I give them to you, I'm not rounding these in I'm not rounding these in my calculator. I'm using these. Okay, so pi over 5t is equal to this number and that number. Because if you think about what it looks like if I have a sine graph, if I have a value, it'll meet the value here and there, or here and there. It's going to hit it twice within a cycle. No matter what value you pick, if it's in the range, it'll hit it at least twice. 0, it'll hit 3 times. But anybody else, it'll hit twice. All right, so I take this number and I multiply it by, so 2 columns, 0.438, so on and so forth, and I multiply it by 5 over pi, because it's the same thing as dividing by pi over 5, because I'm trying to get the t by itself. T is also equal to 2.703, so on and so forth, times 5 over pi. I do it for both of them. Okay, so for the 2.73, if I multiply this by that, I end up with, I can round now, 4.30. And if I take my original value, 4.3 something or the other, hold on. There it is. If I take that value and I multiply it, hold on, messed up. Enter. Times 5 over pi. And I end up with 0.70. These are my 2 times. I feel like we had to break out all of our bags of tricks for that one. You asked me if you need me to explain this one to you more. This one was a little challenging, but it was fun. Let's continue. Another slightly challenging problem, but it's not bad. So 2 sine of 4x plus 1 is equal to 0. All right, they want all solutions. We like that because that means that, well, I'll show you when we get there. All right, so 2 sine of 4x plus 1 is equal to 0. 4x. 2 sine of 4x is equal to -1. Sine of 4x is equal to -1/2. So here we go. So 4x is equal to the arcsine of -1/2. Now, because we are finding all solutions, we can go ahead. We don't have to necessarily stay within the range or the domain and range of our inverse functions, because it's going to include those anyway. All right, so I get up with 2 answers. So where does sine equal -1/2? So 4x is equal to 7 pi over 6, and 4x is equal to 11 pi over 6. That means that x is equal to, divide both sides by 4. X is equal to 7 pi over 24, and x is equal to 11 pi over 24. Now, they ask for all answers. All right, so if I come back up here, or where the answer would be, and I have 7 pi over 24, and I have 11 pi over 24, plus, well, how far is one cycle, or one period? That is 2 pi over b. B is 4. So that is 2 pi over 4, which is pi over 2. So that becomes 7 pi over 4 7 pi over 24 plus pi over 2k, where k is in the family of integers. And this is pi over 2k, where k is in the family of integers. That's your answer. It changes because the period changes. I also could have said pi k over 2, but to me that makes a little more sense the way I wrote it. Alice should take both. If it doesn't, let me know. All right. Last problem. Same type deal that we've been doing before, right? Only a little fraction in here to throw us off. So 2 cosine of 2x over 3 plus root 3 is equal to 0. 2 cosine of 2x over 3 is equal to negative root 3. Cosine of 2x over 3 is equal to negative root 3 over 2. We're in an interval this time for our answer. Always look for that first. So 2x over 3 is equal to the arc cosine of negative root 3 over 2. Where does cosine of theta equal negative root 3 over 2? That means that there are 2 places. 2x is equal to, what is that called? 7 pi over 6, and 2x is equal to 11 pi over 6. These are the 2 places from 0 to 2 pi that that cosine of x is equal to 2x over 3. Sorry. These are the two places where cosine of x is equal to, or cosine of theta is equal to negative root 3 over 2. So now I'm going to multiply both sides by 3. Let me change colors. I haven't changed colors once this time. I'm going to multiply both sides by 3 over 2. That's going to get rid of my fractions, at least in front of my x, which is what I want. 3's cancel, 2's cancel. X is equal to 7 power 6 times 3 over 2. Hope your math skills are still good. All right, this ends up with 7 pi over 4. And this one ends up, this cancel, 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 cancel. This ends up with 1, 2, 11 pi over 4. That doesn't sound right. Negative root 3 over 2, no. Negative root 3 over 2 is, no, it is 5 pi, 7 power 6, and 5 power 6. Yeah, I'm tripping. Y'all gotta remind me, I can't be messing up my unit circle. You know, that's our bread and butter. 5 power 6. So now it cancels, boom, boom. So this ends up being 5 pi over 4. There we go. I knew something looked funny about this because I did these problems before the video. So boom, that's our answer. And that concludes our video. Questions, definitely ask them. I understand this was a little more challenging, but thankfully there's one more that's probably comparable as far as challenge, and then we'll be past the hard part. So any issues, definitely feel free to let me know.